Hello everyone. This video I'm going to explain your homework problem 9.49. Yes, I think this problem should be yeah should have some explanation because I don't think this problem this homework problem give you a complete description of complete description. I think it miss lots of things. And also, I don't think the answer provided by this textbook is correct. I don't think the answer from the textbook is correct. Okay, so let's first of all just view read this problem description. It say 1100 kilogram freight car at rest, and then against a spring bumper at the end of the railroad track. It just let's just say this freight car, and there is a spring attached on this freight car. Okay, I will show you the schematic picture later. Initially this freight car is at rest, and the spring has a constant elastic constant 0.32 million. Okay, it's capital M is million newtons. Medium medium Newton. Sorry, not medium, mega. I always spell this wrong. We pronounce it wrong. Mega. 0.32 mega Newton per meter. And the car is hit by a second car. You say the freight car hit by a second car, and this car has a mass 9,400 kilogram, and its velocity is 8.5 meter per second. And then after the heat after after this collision, these two car couple together, and this means this after this collision, these two car move together. And it said find the maximum compression of the spring, and the speed of these two car when they rebound together from the spring. So it just say when this after initially there's a car at rest, and the other car is moving and hit this car, and then after they hit together and move together, okay, doesn't split. But after some period of time, and then because there's spring, after all they will rebound. Okay, so this is initial situation hit the car move together, but after a certain period of time they gradually separate apart because there's a spring between them. Okay, so okay, I think I should use the graph. It's much clear and not use. Okay, so this is just a problem description from 9.49. Okay, first of all, you have a car here attached to a spring, and then there's another car hit from the left and the velocity, and then after the impact, these two move together. This whole system move together. And then after a certain period of time, because there's spring, and then after the collision is compressed, the spring is compressed. But after a certain period of time, the spring will stretch back to its relaxed situation, and then these two cars rebound. Okay, so you want to try to okay. Let me see. The problem want to find the maximum compression. Okay, let me see. What's the problem want? Okay, maximum compression of the spring. That's the first problem. And what's the second problem? What's the second? What is trying to? What is the second one? Let me see. What's the second one? Not this one. The second one. What is the second one? Oh, the speed after. Okay, after speed. Okay, after these two car rebound. What is okay? How do we this? What's notation is better? Okay, so what's the V1 prime? What's the V2 prime? Okay. Okay, and first of all, okay, so let's to start to answer this problem. V1 prime, V2 prime. Okay, let's start to solve this problem. But this problem, I don't think it states very clearly. Okay, first of all, when this car moved to collide with M2 and then they move together, actually this is called this part is inelastic collision. Okay, why it's become elastic collision? Think about the ballistic pendulum. Okay, ballistic pendulum. Maybe I just open it. Elastic pendulum. Okay. Sorry, ballistic pendulum. Okay, let me try to find a ballistic pendulum. Where is a ballistic pendulum? Let me. Okay, here. It's a very. Mhm. Okay, so here it is a ballistic pendulum. Okay, here is first of all, this capital M is at rest initially, and there's a bullet comes from the left, and then after this small M strike into the capital M, and then they move together up. Okay, and move up, right? The bullet strike into the capital N, and they move together, and at the ballistic pendulum, I ask you to calculate what's the kinetic energy before the strike and after the strike. Okay, and we found the kinetic energy is not the same before the collision and after the collision. So this is the inelastic collision. Okay, so same thing happened in this problem. Uh, Actually, the wrong one. Correct the wrong one. Okay, this one. Yeah, same thing happens here. Okay, initially this, oh, strange. Okay, ah, sorry. Sorry, oh, sorry. Sorry. Yes, yeah. I use the wrong pen. Sorry. Okay. Yeah, I use the wrong pen. Okay, Same thing happens here. Initially, this M2 is at rest. Okay, and the M1 strike M2, and then they move together, just like the ballistic pendulum. So this part is inelastic collision, and the second part, because the springs compress, and then after some period of time, this M1 M2 rebound. Okay, so this part is elastic collision, but I don't. But the problem didn't tell you the second part is elastic collision. I think the this problem should tell you if the second part is a elastic collision. Okay, maybe he think, okay, this is a spring here, so that's what this is a spring here, so the second part should be an elastic collision. But I don't think that's really true. Okay, if you're spring, so the second part must be the elastic collision. No, I think the problem should tell you the second part is the elastic collision, but the first part is an inelastic collision. That's very sure because these two after the impact, these two the whole system move together. That's definitely the inelastic collision, like the ballistic pendulum. Okay. Let me rewrite the question. Okay, so first of all, the question want to find the maximum compression of the spring, and the second part is V1 prime. What's a V2 prime? Just after the elastic second part, after the second part of the collision, what's the velocity? Okay, so let's look at this first problem. The first problem is the inelastic collision. Here I use the concept called internal kinetic energy. Okay, because the problem want to find the maximum compression. maximum compression. Problem want to find the maximum compression of the spring. And in previous lecture, I said what's the meaning for the internal kinetic energy? What's the meaning for the internal kinetic energy? Do you remember that? Internal kinetic energy is maximum possible, maximum possible kinetic energy you would lose. Kinetic energy would lost would lose during the inelastic collision. Maybe I should put it here during the inelastic collision. Yeah, the meaning of the internal kinetic energy is a maximum possible kinetic energy would lost during the inelastic collision. Because the first part is the inelastic collision, so that must be some kinetic energy lost. And I assume because this if I just assume because you want this problem want us to find the maximum compression of the spring. So my idea is okay. I think in this inelastic collision, I just assume it's lost the maximum possible kinetic energy. Okay, it lost the maximum possible kinetic energy. It lost maximum possible in kinetic energy, and this lost energy convert to the elastic potential energy. Okay, this lost energy. Okay, and let me write down my idea is this. Let's pen. Sorry. Not this. The wrong pen. Okay, my idea is this maximum possible kinetic energy was lost. Okay, and then elastic potential energy. Convert to convert to the elastic potential energy. Yeah, that's my idea. I just assume I lost the most possible kinetic energy, and this transferred to the elastic potential energy. That's why you will have the maximum compression. Okay, that's my idea. So my calculation for the first problem actually easy. So I just calculate the internal kinetic energy, and in a previous lecture, I introduced how to calculate internal kinetic energy easily. Do you remember the formula? I think maybe you forget. There's a lecture I say internal kinetic energy is 1/2 nu times V12 square. V12 is the relative velocity between object 1 object 2, and nu is reduced mass, and nu is this is the way we calculate reduced mass. Yeah, remember that? Okay, so let's put this back into the equation. All right, put this. Let's just substitute the information of the problem. Okay, so what's the M1 and M2? M1 I remember is 9400, right? 9400. Okay. M1 is 9400 kilogram. Okay. M2 is I think more 11,000 kilogram. And V12 because is 8.5 minus 0 because initially one is at rest and the other is velocity 8.5. Okay, so our internal kinetic energy, yeah, you can calculate the nu. You can calculate nu by yourself. Okay, actually it's very easy. It's M1 plus M2, M1, M2. and 8.5 minus 0 square. So what's the internal kinetic energy? Okay, so M1, M2, M1, M2 is if you- and divided by 9400 plus 11000. Okay, and times 8.5 square and divided by 2. Okay, I'm not sure my answer is correct. Really. Okay. So okay, let's calculate again. 94 divided by 94. Hmm. Okay. Times 8.5 square divided by 2. Okay, because the number is huge, so I just don't take any small don't take any digit. Okay, don't take any digit. The number is small. It's one. Sorry, it's wrong. Sorry. It's a wrong pen again. Sorry, wrong pen again. It's 183,104. Okay, and the unit is joule. Okay, and this is converted to, and this is converted to the elastic potential energy 1 over 2. What is K? K is 0.32, right? Oh, K is 0.32. Okay, Kx squared. Okay, so K is 0.32 mega Newton per meter. Mega, what is mega? Mega means 10 to the power 6. So it's 104 equal to 1.2 times 0.32 times 10 to the power 6 times the x squared. So what is the answer for x? Let's calculate it. 13104 times 2 divided by 0.32 divided by 10 power 6 and take a square root. My answer is 1.06. Okay, 1.070 meter. Okay, that's my answer. That's my maximum compress of the spring, 1.070 meters. I think the textbook give you another answer, but that's I think this is my view to this problem. I think this should be the right answer. Okay. Okay, so the second problem. Okay, the second problem actually is easy. Okay, so a second problem after I say the second part after the elastic collision, what is V1 prime and V2 prime after the second part of collision? The second part is the elastic collision. Okay, so actually it's very easy. So first of all, we calculate what's the velocity at this state. Okay, let's first of all calculate that. Let's call VF because the whole system move at the same velocity, right? We calculate. Let's calculate the VF first. Okay, because let's say uh, yeah, in elastic collision, the momentum still conserved. Okay, okay, that's the first part. Okay, the momentum still conserved. Okay, also it's an inelastic collision. The momentum still conserved. So, okay, so Pi equal to PF. Okay, so initially the mass is moving 9400 and times 8.5. And then at the final state, they move together. Okay, this system move together. So it's M1 plus M2 times VF. That's the that's the VF. Okay, that's M1 plus M2 times the VF. Okay, so VF is easy to calculate. I think it's 3.2 something. Okay, let's do the calculator again. So 9,400 times 8.5 divided by 9,400 plus 11,000. Okay, so, oh, sorry, 3.92. Okay, 3.92. 3.92. Okay, so at this stage, these two block move to 3.92. 3.92, and okay, this also 3.92. And he want to calculate after this elastic collision, what's the velocity v1 prime, v2 prime. So it's very easy, right? Because elastic collision, we can use the two, right? The two equation to solve this problem, right? Remember that? Okay, so after elastic collision, part is okay. First of all, the momentum is times Vf 3.92 equal to 9400 V1 prime plus 11000 times V2 prime, right? Right. Okay. And also, okay, we have another equation. V1 minus V2 equal to V2 prime minus V1 prime. The V2, V1, V2 actually is VF minus VF. So actually this is zero. So let's tell you after the second part collision, V1 prime equal to V2 prime. Okay. So we have these two equations. Okay, so we can solve the problem very easily. So after the elastic collision, what's the V1 prime, V2 prime? It's very, very easy. So let's say, okay, so 9400 plus 11000 times 3.92. But V1 prime is equal to V2 prime, so we can substitute one of them. So it's equal to 9400 plus 11000 V1 prime. So and divided. So after the second part of collision, V1 prime is 3.92 and V2 prime is also 3.92. Okay, that's my answer for the second problem. I think the textbook still also give these answers. Okay, but my only different opinion is the answer for the first problem. I think the maximum compression of the spring should be 1.07 meter. I think what's the answers? What's the answers? Do I have its answer? What's the answer tell you? What's the answer? What's this problem? 9.49. Okay, 9.49. Okay, 9.49. 9.49. The answer could tell you about 0.99. I don't know. I really don't think this is the answer. I really don't think. Okay, so that's my view to the first problem. Okay, and the second problem the answer should be the same with as the textbook. Okay, so okay, here's my explanation for the 9 point what 9.49. Yeah, 9.49. This is my explanation for 9.49. So if you have different opinion, yeah, just come to discuss with me at the after the class. Okay, I think this should be, yeah, this is the same, and this should be use the internal kinetic energy to solve the problem. Okay, okay, see you in the next video. Bye bye.